All right, AP Chem, here's what we are working on right now. I want you to think about where we've been for a couple of units right now. We have just finished up a couple of units back, a unit on gases, and this unit we are just finished yesterday, or today, or whatever day you're watching this video, I don't know, liquids and solids. And so now this particular chapter kind of mixes those together. It's on solutions. So let's get rid of that. We don't need that on the screen. So I want to, with this particular chapter, there's a couple of major things that we're going to be looking at in terms of solutions. Now, solutions could be mixtures of gases. Think of air, for example. It could be a mixture of a solid and a liquid, you know, salt water, for example. It could be mixtures of liquids with liquids. Alcohol, for example, mixes really easily with water. So it could be a large variety of things. What I want to do in this chapter, we're going to look at a couple of things. First is units of concentration, and there's a wide variety of them that you need to know. And the second thing that we will move into next week is colligative properties, which are some properties of solutions that we're going to be interested in. But today we're simply going to focus on the units of concentration. And I'm just going to give you some. You should definitely copy these into your notes. And yeah, you're going to have to memorize some of them. Sorry, guys. First one's really easy. Molarity. You already know this one. But molarity is defined to be moles of solute per liter of solution, which begs, you know, we just typically have been using moles per liter, which begs a little bit of vocabulary, of course. The idea of solute versus solvent versus solution, which is the combination of them. But solute is usually what gets dissolved by the solvent. And that's usually pretty easy. If you have, you know, a liquid and you put some solid in it, the liquid would be the solvent and the solid would be the solute. Where it becomes a little bit more difficult to decide is, for example, if you take one liquid and you dissolve it in another liquid, then who's the solvent? And generally, it's whichever one there's more of that we will tend to use that idea. The one there's more of is the solvent, and the one that there's less of would be the solute. So, you know, it gets a little tricky when they're both liquids, or if they're both gases, for example. All right, so moles of solute versus, back to molarity, just sort of, that was a little side note that we needed to know. So you guys know how to use this. I'm not too concerned about it. Second one, mole fraction, which is designated by an X. In order to find mole fraction, the mole fraction of some substance A is defined to be moles of that substance A divided by the total moles. And depending on your purpose, you might want to use a different unit of concentration. Any way we look at it, these units of concentration, which is what we are looking at right now, can tell us how concentrated or dilute something is. So higher molarity versus lower molarity, higher mole fraction versus lower mole fraction. What we're really looking at is how concentrated it is. But different things are measured in different numbers. Molarity we've obviously used quite a lot. Mass percent is another one. And if you were trying to find the mass percent, if you wanted the mass percent of, say, substance A, that would be equal to the mass of substance A divided by the total mass. And then you multiply it by 100 in order to make it a percentage. Some things are measured that way. For example, vinegar in a store is often said to be 5%, and it's 5% acetic acid, and that is a 5% by mass solution, actually. Another one is volume percent. And so now this is how concentrated is it by way of volume. So if we want the volume percent of substance A, that would be the volume, milliliters, liters, doesn't matter as long as there's consistency in the units, divided by the total volume. And again, times 100. Actually, alcohol, very often in the stores, actually wine, And no, I do not expect you to know that offhand. I'm just trying to give you an example. Wine is often sold by percent by volume. They tell you what percent of that volume is alcohol out of the entire substance. So this one is less common, and I'm going to tell you guys, if all you're given in a problem is it is something percent, and they don't say volume percent or mass percent, always assume it's mass percent unless you are very specifically told it's volume percent. So, you know, don't come asking me if I give you a question on a test and it says it's, you know, 13%, you know, acetic acid, and you start running up to me going, well, is that a volume percent or a mass percent? It is a mass percent. I'm not going to answer you. Yeah, that's just me. Okay, how about number 5? ppm, parts per million, is another one. This one's used a lot, especially when your water is tested at home. They sometimes are testing for very small impurities, and they use this idea of parts per million. You know, if they gave you molarity, that's something I guess they figure the general public doesn't know what that means, but parts per million, maybe they do. It also is parts per million if you're talking about really small amounts. Instead of having a molarity that's like 0.0000, you know, something 15 molar, it's easier to give parts per million, which ends up being a bigger number. Here's how you compute. Here's the easiest way. There's multiple ways to compute parts per million. Here's the easiest way. Simply take the milligrams of your solute and divide it by the kilograms of the entire solution. A milligram is 1,000,000 times smaller than a kilogram. So if you take milligrams divided by kilograms, then what you get is parts per million. So that's a nice, easy way to do it. All right, last one. And then I'll show you an example problem. Molality. This is designated as little m, don't write big M. Think about that, you guys. Why would we not want to use big M? Okay, moving on. Molality is, by definition, moles of solute per kilogram of solvent. So this is just a different unit. We're going to use this one quite a lot in some of the colligative properties that we'll be talking about later. So it will have a role in there. So again, yeah, write them down. You got to memorize these in order to use them. What is going to be sometimes more handy is sometimes you're given a concentration in one unit and you're not interested in that unit. So you want to find a new unit of concentration. So I'm going to do an example problem with you. And that example problem is, what is the molarity of a 15.2% sodium chloride solution that has a density of 1.10 grams per milliliter. This is a pretty typical problem where you are given one kind of concentration unit, but you're interested in a different kind. And we're going to be practicing some of these in class. So here's the thing. You actually are not given any information about what the size of your sample is, like how much. It's difficult to work numbers if you don't know how much. So the easiest thing to do here is to assume a sample size. And the size of your sample should really be dependent on what you're given. Now notice, you guys, I just said 15.2% sodium chloride. Don't ask me if that's a percent by volume. It's not. This obviously is referring to mass percent because I'm not told otherwise. So that really, you know, is grams of NaCl over total grams. So I would probably want to choose a sample size that was in grams. If, for example, my units were given in molarity, you know, which is moles of solute per liter of solution, I would probably want to assume a liter of solution, or a certain number of liters. It's probably easiest to assume one. So use the unit to help you decide what kind of sample size to assume. If I'm given this, as I was, I'm going to assume it in grams. So I'm going to assume I have 100 grams of solution. Because if I do, that gives me some information. Like, oh, then 15.2 grams is sodium chloride. It also, if it was helpful to me, would give me some information like it's 84.8 grams of water. So I know that to be true as well. But I need moles. I want molarity here, so I want moles of sodium chloride per liter of solution. So let's start with this. I can get moles of sodium chloride. So I have 15.2 grams of sodium chloride. Change that into moles. And I get some number of moles of NaCl. You know, if you're clever and you have your calculator out, you can figure it out. I don't personally care what that number is right now, but you should. All right, then the other thing I need is I need to get liters of solution. Now, I know I have 100 grams of solution, and if I go back to the problem, something that's going to help me go from grams of solution to liters is the fact that I have this density right here. If I can convert to grams to milliliters. So in this case, I know it's 1.10 grams per milliliter. I know there's 1,000 milliliters in a liter. And so that gives me however many liters of solution. So if I want to find my molarity, which is what I was ultimately asked to do, that's going to be equal to these moles of my solute here divided by my liters of solution, which I have just calculated here, and I can divide it out and I will have my molarity. So we're going to practice some of that in class, so bring your book and be ready.